So put-call parity 1 in the book is taking really a version 1 approach. And that is, the author is looking at a call minus a put. And noticing that the value of a call minus a put is, in fact, the present value of the forward price minus the strike. So if you write it down that way in the author's notation, you have that the value of the call minus the value of a put is the present value of the forward price minus the strike. Recall that this F sub 0t is the author's notation for the forward price from time 0, the forward price at time t for the stock S. And so that would be the same expression we had before, namely that the forward price at time 0 is exactly S, when there's no dividends, e to the RT. Now, what if they have dividends? Well, the dividends change the forward price. The advantage of the way the author expresses the equation in terms of forward prices, and we saw this with the original version 1, is that the forward price is automatically adjusted in the presence of dividends payable by the stock. So in the case of a stock that pays discrete dividends, the equation becomes call price is put plus the forward value, the present value of the forward value. What is the present value of the forward value? It's the current stock minus the present value of the dividends. And that's because of this relationship here, that the forward value is the accumulated value of stock minus present value of dividends. So consequently, the present value is just stock minus present value of dividends. On the other hand, if you have an index option or an option that pays a continuous dividend, and indexes can be approximated by that, then the adjustment for the forward price is S0 e to the minus RT. And that is because the forward price for stock with continuous dividends is the initial price accumulated with risk-free rate minus the dividend rate to time t. So when we do a present value of that, we get the S0 e to the minus delta t. So this is the more general these are the more general versions of put-call parity in the presence of discrete dividends and continuous dividends, and they adjust the insights we had before in the simpler case. Now we can look at version 2, where we think about constructing these portfolios. Namely, in a discrete dividend context, what would our portfolio A be? We would buy a call on S and a T-bill, maturity K. In other words, portfolio A is the same if we have dividends on the stock. It's portfolio B that changes. If we have a share in portfolio B, we bought a share of stock and a put on stock. Well, if we have a share on stock, we can also short a T-bill equal to the present value of the dividends. The reason is, since we own the stock will pay our dividends, and those dividends can be used to cover that short T-bill. So portfolio B decreases in value because we can short a T-bill equal to the present value of dividends and repay that short position with the dividends the stock provides. If we have continuous dividends, portfolio A is again a call on S and a T-bill, maturity K. That doesn't change. It's the stock side, portfolio B, that changes. If we have continuous dividends, the adjustment is we no longer need one share of S. We only need e to the minus delta T shares of S. And the reason is that that number of shares will grow to one share as continuous dividends are paid and we reinvest those dividends in new shares of stock. And the present value number of shares will grow to one share, and we still have a put on S. So we can look at a couple of examples from the book, example 9.1 and 9.2. In example 9.1, we have a non-dividend stock, price of 40, risk-free rate of 8%, strike of $40 as well, so this is an at-the-money option, and it's a 3-month expiry. So T would be 0.25 because we measure time in years. The European call has a price of $2.78 and the European put $1.99. And we can see by doing the arithmetic that $2.78, price of the call, is the price of the put plus the price of the stock minus the present value of the price of the strike. On the other hand, what if the stock pays $5 right before expiration? The only significance of it paying right before expiration is we can use the same present value factor as the T-bill. If the dividends were payable earlier, then we would use a different present value to make this adjustment. On the other hand, if it were paid after the expiry, we could ignore it for put-call parity. Important note, put-call parity only reflects discrete dividends payable prior to expiry. In that case, the call drops to a value of 74 cents from 278, and the put goes up for 85. First of all, intuitively, why does that make sense? Why should the value of the call drop after a dividend pays? Well, when a dividend pays, the value of the stock goes down. In fact, the value of the stock drops exactly the same as the value of the dividend paid. So a call is the option to buy. So if we have a stock whose value is predicted to drop, the option to buy it, it diminishes. The value to buy it at a fixed price diminishes. On the other hand, the value to sell it at a fixed price goes up because the value of the stock goes down after the dividends paid, and consequently it's more valuable to have an option to sell it at that fixed strike. So predictably, the value of the call goes up, the value of the the value of the call goes down, the value of the put goes up, and once again, the put-call parity is satisfied. And here you can see that we have the $40 price of the stock minus the present value of dividends payable prior to expiry. And again, if they were payable at a different time prior to expiry, we would simply adjust the present value factor to the appropriate payment date.